Hey guys, I'm back with video 2, and this video is about question 10 from assignment 5 in our stats class. And you can see right here that I've copied the question from Pearson and I've got it here in Excel. So this one is about binomial distribution, which is different from the probability distribution we did before, and I'm just going to go through all 5 parts of this question and we'll work through them all. So the first thing to point out are the two formulas. So we have the formula for the mean and the formula for the standard deviation. And to be totally honest, I don't understand these formulas at all. So over here, I'm just going to kind of go through the math that I sort of worked out that will give you the right answers without sort of these formulas that are too complicated for me. If you've seen Excel sheets I've made before, you'll know that the blue numbers, the blue cells, are cells we're going to fill in manually, and any green cells are cells that are going to have formulas in them. I've also color-coded these cells, which we'll sort of get to in part C of the question. I'll sort of explain that. So N is quite simple. It's the number of trials or people surveyed or the size of our sample. So if we look at our question, we can see that there are 6 people in each sample group. So even though presumably all of the 18 to 29-year-olds in this country were surveyed, each of our samples are the size of 6. And the other thing that sort of confused me was the word next in here. I kind of read that as next, sort of taking into account the sample that had happened before. But in the context of this question, next doesn't actually mean anything. Each sample is a sample size of 6. And that doesn't affect the sample before it. So our n is going to be 6. So we're going to enter 6 right here. Now p is our probability expressed as a decimal. So we can see up here that 37% of these people own tablets, which means that our probability of someone owning a tablet is 0.37. 1 minus p is very simple. It's literally just 1 minus the value of p, so 1 minus this cell, which gives us 63% or 0.63. And to some extent, this is going to make logical sense. So if 37% of people own a tablet, then 63% of people don't own a tablet. Which brings us to mu, or our mean. And to calculate the mean is actually incredibly simple. All we're going to do is multiply the sample size by the probability. So we're going to press equals. We're going to multiply 6, our sample size, by 37%, our probability. And this will give us a mean of 2.22. And if we look up at the answer here, we can see that that's the correct answer. And for standard deviation, this is a lot simpler than it was with the previous video. What we're going to do is we are going to take the square root. We're going to multiply these 3 numbers together and take the square root of it. So we're going to use the square root function. And then we're going to multiply 6 times 37% times 63%, close our bracket, and we're going to get 1.182624. And if we look here, we can see that that's the right answer. That's our standard deviation, or our sigma. Now we're going to sort of tackle A, B, and C. And these are the questions that rely on the binomial distribution. And to do that, we're going to fill out our chart up here. And we're going to use the binomial distribution formula. So you're going to press equals, and you're going to start typing it out. And you're going to see it right there. And you can auto-complete the formula by clicking on it twice. So this is going to consist of sort of 4 parts. So number S means the number of successes. So you can kind of see over here that even though we have a sample size of 6, we actually have 7 possible outcomes. Because it is possible that of the 6 people we survey, no one owns a tablet. So think of S as number of successful trials. The number of people who own a tablet out of the 6. So our first one is going to be 0. Actually, we won't type 0. We click on this cell. Next, we want to know trials. And trials is the number of people we surveyed or the number of people in the sample. So in this particular case, it's 6. The probability of success. So the probability that a person owns a tablet is what goes in this next part of the function. And we know right over here that our probability is 37%, and we're going to express it as a decimal. And finally, we have this. This is cumulative. And when we want an exact number, when we want to know the exact percentage, how likely it is exactly that 0 people own a tablet, we don't want to add up or subtract anything from here. We want to know the exact number. And to get that exact number, we're going to use the false function here. And that'll tell us that there's about a 6.25% chance that 0 people own a tablet. And we can fill this whole chart in really fast by dragging down our formula. But the thing we have to remember about that is that these two values, 6 and 37%, will never change. So it's going to be constant through all of our samples. We'll always survey 6 people. That will be our sample size. And the probability of them owning a tablet will always be 37%. So since we're always going to test against those two numbers, we're going to absolute value these two cells. And then we can drag this down to fill out the rest of our chart. Now, I've used a lot more decimal places than the teacher uses or Pearson wants, but it doesn't really matter as long as you're careful with your rounding. And another thing to note is that you can see this as a sum function down here. So I've summed up all the probabilities. And it's equal to 1. So that makes logical sense if you think about it. That's 100%. So it means that when we take a sample of these people, we'll always get one of these answers. We won't ever get 7 people if we take a sample of 6, and we won't ever get -2 people in a sample of 6. 100% of the time, when we survey 6 people, we'll get one of these 6 answers. And this is the percentage chance of getting each answer. So now the question is asking us, what is the probability that 4 people own a tablet? Well, we can look right here in our chart, and that will tell us the probability. It's 0.11578,175. But we're going to round it to 4 decimal places. And we can see that's the right answer. And B will ask us, what's the probability that all 6 people will own a tablet? So we can actually just look right here, right next to 6 at our function there, and we'll see that there's a little less than 1% chance that 6 people will own a tablet. And these are the same. We've just rounded that 6 has just rounded that 5 up to a 6. So we can see that we get the right answer here by matching it to our table. Now this is where it gets a tiny bit tricky. So we want to know in a sample of 6, what is the chance of at least 4 people owning a tablet? So this is sort of where the color coding comes in. So if we had a sample of 6, we would essentially say that if 4 people own a tablet, 5 people own a tablet, or 6 people own a tablet, those are sort of all successful surveys because 5 and 6 are greater than 4. And we want to know how likely it is that more than 4 people own a tablet. So in my opinion, the easiest way to get the answer to this question is to just sum these 3 values. So we're going to sum those 3 cells. We're just going to use our sum function, select these cells, close the bracket, and that will give us our answer. And as again, you can see I've used a lot more decimal places than the teacher does, but with rounding, that does give us the correct answer. Now, the other thing is that this is a small table and it's quite easy to read. We only have 7 total variables. It's possible we were dealing with a chart that has thousands of variables, and in cases like that, it would be very difficult to just pick out the cells we want and sum them. So there is a way we can sort of do this automatically with the binomial function. And to do that, what we want to do is we want to know how likely. So what we want to do is we want to count all of these and we want to subtract all of these values. Because remember, if 3, 2, 1, or 0 people own a cell phone, we don't care about that. We only want to know how likely it is that these people own a cell phone. So what we're going to do with that is we're going to press equals 1. So if you see this is 1, that's our 100%. So think of this one as that one. So that's our 100% minus the cumulative percentage that these represent. We're going to subtract off all of these because none of these would be successful in a situation where we're only considering 4 or more. So we're going to go 1 minus, and we're going to put our binomial function in, and we're going to start at 3. And so this, because we've hit 3, this is going to total all of these light gold cells. It's going to total all of these up and subtract them from 1. So we do have the same number of trials, 6, the same probability, 37. And then we want to know if it's cumulative. So remember how before we used false because it only considered the one variable? Well, now we want to add up everything that's 3 or lower. I've screwed up this formula now. So now we want to add up everything 3 or lower. And true is cumulative. That'll add everything below the number, everything inclusive of the number and below it. So this is going to add all of these numbers together and subtract them from 1, essentially taking these completely out of our 100% to show the final percentage, the likelihood that it's 4, 5, or 6. So we're going to click on true. We're going to close our bracket and we're going to hit enter. And we're going to see that this gives us the exact same number as just adding up these final 3. And that's everything about this question. That's all you need to know.